Hello, calculus fans. It's Mr. Peabody here, about to share with you solutions to what I call this number 6 this would be reading derivative graphs. We have not done a lot of this, in fact, at all like this, where you are presented with the graph of f prime of x. So this is a derivative graph. Which means it's not the original function, it's the graph of the derivative. It's the graphs of the slopes of tangent lines, which means early on in our careers here, before we were really reading derivative graphs, it's really hard to do. So each of these problems here just has you compare either f prime of a number or f of a number or even f double prime and compare them. So I'm going to take you through how to kind of think through and answer these questions. So this is a derivative graph, and that means it's the slopes of tangent lines. So I'm just going to outline here this area here where the derivative is above the x-axis, or the y values are above the x-axis. That means f prime is positive, and that means f must be increasing. So f is increasing. That is until we get to this point 1, in which point the derivative is negative. So this is the place where here the derivative is negative in this interval. So that means f, the original, is decreasing. And so that point that where f has gone from increasing to decreasing, or where the derivative is positive and then goes to negative, means that that 1 right there is a relative max. That means the function has been increasing until we get to that point 1, and then it's decreasing. That means it's reached a peak, also known as a relative max. All right, so let's go here with the first one, f of 0 compared to f of 1. So because the function is increasing here, that means that it's going up and up from left to right, and so that means f of 0 is going to be less than f of 1 because the function is increasing it from as far as we know, like here up until 1. So f of 0 is less than f of 1. Second one talks about the original f graph, f of 1 versus f of 2. Well, now our eyes go right here, and we see that since the function is decreasing, what was more left was higher than what's more right. So that means f of 1 would have been a little bit higher somewhat than f of 2, so that means f of 1 is greater. Let me change to red. F of 1 is greater than f of 2. Those are tough because those are the f graphs. Now the C and D, I'll highlight those. Those are real nice because they're asking about the first derivative, of which the graph we have right there in front of us. So what is f prime of 0? Your eyes go to 0 and they go here. And that means what's the slope of the tangent line there? I know that that slope is negative. F prime of 0, the slope, the value of it, I need to go back. This is a derivative graph, so the slope is positive, which means it's bigger than 0. So the derivative is slope at 0 is bigger than 0. But when we get to f prime of 1, that's right here. That's reading the graph directly. F prime of 1 is 0, so that is equal to 0. Okay, let's see. I'm going to erase everything right now because we're going to talk about the second derivative graphs, and so I think it might be good to clear stuff. So we look at now part E. F double prime of 0. your eyes should go to the derivative graph and say, what is the slope of that tangent line at 0? That's this. That's going to be a negative number. It's going to be less than 0. And then letter F is F double prime of 2. That's the second derivative. So that is the slope of the tangent line of the first derivative. My eyes go here. That looks to be a horizontal line. F double prime of 2 is equal to 0. Now, it might be good here just to kind of share with you that if you want, sometimes it's nice to kind of practice going back to the original function. So the original, let's see, here at this area we are increasing, and then at 1, that's a relative max, and then we're decreasing. So that means most likely it's going to be something like, here I'm going to put 1 and 2 in there, and that means we are increasing until we get to 1, then we're decreasing until we get to 2, and then we're kind of bottoming out because that slope of tangent line is getting closer to 0. This slope is getting closer to 0. We haven't talked about it, but this point right here at 2, that is where if we're F prime is decreasing, that means we are concave down. And then at this point where F prime is increasing, that's concave up. So I think that's what the original function would look like, is F of x. It's a hard exercise to do, and you do not have to kind of work back, but it might be good to find, if you're looking at the derivative graph, to go back to what the original looks like.